The elevator stopped between the 12th and 13th floors of the Riverside Administrative Tower during a routine maintenance inspection. The halt itself did not raise concern. Elevators stopped between floors frequently during service checks. What drew attention was the way the car resumed movement afterward, continuing upward without any command from the control panel and without the drive motors engaging. Inside the shaft, the steel cables remained motionless. Yet the elevator car continued rising. Maintenance staff reviewing the building's lift system had initially been conducting a scheduled calibration of the tower's load balancing sensors. The building used a conventional traction elevator design, counterweights, steel suspension cables, and a motor assembly positioned in the rooftop machinery room. Movement required the motor to rotate the drive sheave, pulling one side of the cable while lowering the other. The inspection team had disabled that motor during the test. Power to the drive assembly had been physically disconnected at the breaker panel. When the elevator car halted between floors, technicians assumed the safety system had engaged because of the temporary shutdown. The expectation was simple: the car would remain suspended until the inspection concluded. Instead, the cabin resumed movement. The cables remained stationary. Video from the shaft cameras confirmed the configuration clearly. The cable bundle hung vertically through the shaft, unmoving, while the elevator car, still attached to that bundle, began sliding upward along it. The movement resembled a bead traveling along a wire. The technicians first assumed the video feed had frozen or desynchronized, but the shaft lighting shifted with the car's position, and the floor markers mounted to the concrete walls passed steadily behind it. The car was physically changing height inside the shaft. The cable assembly did not. Technicians watching the monitor described the motion as independent. The elevator was traveling along its own suspension cables without pulling them. At that stage, the incident remained confined to the mechanical control room. No passengers were inside the elevator. The car had been locked out for maintenance earlier that morning. The inspection team paused their calibration work and began checking the mechanical restraints that normally prevent free movement when the motor system is offline. The traction brake had engaged correctly. The counterweight was stationary. The steel cables were under tension, but showed no sign of rotation around the drive wheel. Yet the elevator car continued moving upward. The car passed the 13th floor marker, then the 14th. The shaft camera revealed another detail that complicated the situation further. The elevator rails, two vertical steel tracks bolted into the shaft walls, guide the cabin's wheels and prevent lateral sway. If the cabin moved upward while the cables remained fixed, the rails should have forced friction against the guide rollers. But the rollers appeared unaffected. The elevator was traveling along the rails without compressing them. One technician suggested the car might be drifting due to a counterweight imbalance that had gone unnoticed when the motor was disconnected. That explanation lasted only long enough for the counterweight camera feed to come into view. The counterweight remained at its original position near the bottom of the shaft. The elevator car, which should have moved only in relation to that weight, had already climbed 3 additional floors. Both masses were stationary relative to their cables. Yet the car had changed elevation. At this point, the inspection team halted the maintenance procedure and notified the building's engineering supervisor. A temporary building shutdown was considered, though the elevator system involved served only a limited administrative wing during off hours. The car continued its slow upward movement. Its speed was modest, slower than normal elevator travel, but steady. Floor markers passed every few seconds as the cabin slid along the cables. The cables themselves did not rotate. Observers began describing the motion using a phrase that appeared repeatedly in internal notes: relative displacement. The elevator was changing position without altering the cable system that defined its movement. For several minutes, the phenomenon continued without variation. The cabin climbed past the 17th floor and approached the upper mechanical levels of the tower. Then the motion stopped again. The cabin now rested between the 19th and 20th floors. Once again, nothing had activated the drive system. Maintenance personnel in the control room watched the shaft camera, expecting the cabin to remain where it was. Under normal conditions, an elevator cannot move vertically without the cable system shifting or the counterweight responding. Both remained unchanged. For nearly 10 minutes, the car stayed suspended at T height. During this interval, the inspection team attempted a controlled system reset. Power was restored briefly to the drive motor to see whether the elevator's position sensors would correct the irregularity. The moment the motor engaged, the system registered the cabin as still located near the 12th floor, the position where the original stop had occurred. According to the elevator's own control system, the cabin had never moved. The physical camera feed showed it suspended 19 floors above. The reset procedure was immediately halted. Engineers reviewing the control interface realized the elevator system was reporting cable positions correctly. From the system's perspective, the cables had not moved since the maintenance shutdown began. The control software was therefore consistent with the cable position sensors. What the system could not account for was the cabin's position along those cables. Another anomaly appeared in the shaft camera feed. The elevator car resumed movement. This time it traveled downward. Again, the cables remained motionless. The cabin slid along them as though gravity applied only to the cabin itself, leaving the rest of the mechanical system unaffected. It passed the 19th floor marker, then the 18th, then the 17th again. Technicians noticed that the speed remained constant regardless of direction. The elevator did not accelerate while descending, nor did it decelerate when reversing direction. The movement resembled controlled travel, except no mechanism existed that could produce it. During the downward pass, one technician attempted a second system command from the control console. He issued a standard elevator call instruction, requesting the cabin move to the 15th floor. Normally, this command would activate the motor assembly and pull the cable. Instead, the cabin, already descending, reached the 15th floor marker and stopped precisely at that height. No motor engagement occurred. The cables had not shifted. The cabin had simply ceased moving once it reached the requested level. The technician cancelled the call instruction immediately. The cabin remained stationary. For the next several minutes, the shaft cameras showed no movement at all. The cabin appeared locked at the 15th floor height, while the cables, rails, and counterweight remained unchanged. Then the inspection team attempted something else. A second elevator in the same shaft corridor, operating on an independent cable system, was dispatched upward toward the 20th floor. As the second car approached the 15th level, the stationary cabin began moving again. It traveled upward. The cables remained still. The cabin rose just ahead of the approaching elevator in the adjacent shaft, maintaining a vertical separation of several floors. Every time the second elevator changed speed, the drifting cabin adjusted its position slightly higher along its own cables. No mechanical link existed between the two systems. Yet the drifting cabin maintained distance from the moving elevator. When the second car halted at the 20th floor, the drifting cabin stopped between the 18th and 19th levels. Both elevators remained still. For the first time since the inspection began, the maintenance team understood that the cabin's movement was not random. Its position was reacting to activity elsewhere in the building's elevator network. The cabin had begun moving without motor input. It had stopped at a requested floor without engaging the drive system. And now it appeared to be adjusting its location relative to another elevator that shared only structural proximity within the building. The cables continued hanging motionless through the shaft. The counterweight remained exactly where it had been since the inspection began. Yet the elevator car had traveled nearly 10 floors since the first unexplained movement. By the end of the initial observation period, one fact had become unavoidable. The elevator was no longer bound by the mechanical interactions that normally governed its movement. It could occupy positions along its cables without affecting the cables themselves. The elevator system had lost the fundamental interaction that allowed its components to move together. And the cabin was still inside the shaft, still attached to cables that no longer controlled where it could go. By early afternoon, the building's engineering office had shut down all elevator traffic within the administrative tower. The drifting cabin remained suspended between the 18th and 19th floors. No attempt was made to move it. At that stage, the central question was no longer how the elevator had traveled along stationary cables. The more immediate concern involved the conditions under which it might begin moving again. Because the cabin did not appear to respond to the motor assembly. Instead, it responded to other activity. Testing resumed cautiously. Knee elevator in a neighboring shaft was brought online and instructed to descend slowly from the upper floors. The drifting cabin reacted immediately. As the operational elevator began descending, the cabin inside the inactive shaft rose along its cables. The cables themselves remained fixed in place. The relationship resembled mirrored displacement between two separate mechanical systems that shared no physical connection. When the operational elevator stopped at the 15th floor, the drifting cabin stopped as well, hovering 2 floors above it. The spacing remained consistent during repeated tests. Every movement of the functioning elevator produced an opposite adjustment in the drifting cabin's position. The phenomenon did not rely on cable movement or counterweight balance. The cables remained motionless throughout the experiments. The cabin was altering its elevation, while the structure designed to move it stayed still. This created a condition that the building's mechanical systems had never been designed to address. Elevator safety systems rely on friction brakes, cable tension, and guide rails to control movement. All of those mechanisms assume that the cabin's position changes only when the cables move. In this situation, the cables were no longer participating in the interaction. The cabin's vertical location had become independent of the cable system. This independence became more concerning when engineers realized the elevator's safety brakes also depended on cable motion to trigger their engagement thresholds. If the cabin attempted to move rapidly, the braking system might never activate. Testing stopped temporarily while engineers reviewed the implications. During that pause, the cabin remained stationary between the 18th and 19th floors. Nearly 20 minutes passed with no visible activity. Then the building's maintenance corridor lights flickered. The lighting fluctuation itself was minor, but it coincided with a sudden shift in the shaft camera feed. The drifting cabin moved. It descended rapidly past the 18th floor marker. Then the 17th. Then the 16th. The cables remained motionless. The cabin was sliding downward along them faster than any previous movement observed during the tests. The descent slowed as it approached the 15th floor. Then the cabin stopped again, exactly where it had stopped earlier during the control command test. Nothing in the elevator control system indicated a command had been issued. The control interface still displayed the cabin as being parked near the 12th floor. Engineers in the control room remained silent for several seconds before someone suggested checking the building's external elevator request panels. One of the hallway call buttons on the 15th floor had been pressed. The timestamp on the security camera outside the elevator bank showed the button had been activated roughly 10 seconds before the cabin began descending. The elevator had responded to a passenger call, but the motor had never engaged. The cables had never moved. The cabin had simply repositioned itself along its suspension lines to reach the requested floor. At that point, the test area was secured. Hallway access to the 15th floor elevator lobby was closed off, while engineers attempted to determine whether the phenomenon could influence passenger elevators in the rest of the building. During the following hour, multiple controlled call requests were issued from different floors. The cabin responded to several of them. Each time it moved along its cables without altering the cable system. Each time it stopped precisely at the floor that had requested service. The behavior created a condition that engineers eventually described using a phrase that appeared in the internal report: interaction failure within defined coordinates. The elevator cabin still existed physically inside the shaft. It remained attached to the cables, but its position along those cables was no longer governed by the mechanical interactions that normally controlled it. The cabin's movement responded only to operational signals within the elevator system, call requests, nearby elevator motion, and electrical changes within the building infrastructure. The physical system that normally produced that movement had ceased participating. By late evening, the building owner authorized a temporary closure of the affected elevator shaft. Barricades were installed on every floor to prevent access to the doors connected to the drifting cabin. The elevator control system was disconnected from the building's main electrical grid. The cabin remained inside the shaft. Overnight monitoring cameras recorded several additional position changes. Each occurred after activity within the building's elevator network, either a call request or movement from another car in the adjacent shafts. The drifting cabin adjusted its position accordingly. The cables never moved. By the following morning, permanent operational change had been introduced. The elevator control system for that shaft was isolated from the rest of the building's network. No call buttons were wired to it, and no other elevators were permitted to run simultaneously within the same vertical corridor. The drifting cabin remained suspended between the 18th and 19th floors. During the next several weeks, the cabin moved occasionally. Each movement occurred when technicians attempted diagnostic tests on the building's elevator network. Whenever a test signal reached the isolated shaft, the cabin repositioned itself along the cables. The cables themselves remained perfectly still. Eventually, the building owner halted further testing entirely. The shaft containing the drifting cabin remains sealed. The elevator inside it has not been removed. The cables still hang through the shaft in their original configuration, and the cabin remains attached to them. Its position changes from time to time, not because the cables move, but because something within the building's elevator system still interacts with it, even though the physical mechanism that should control that interaction no longer does.